Hey, what's going on, guys? Let's do this problem right here. We have the question that's asking what is the greatest amount of AlCl3 in grams that can be made with 114 grams of Al and 186 grams of Cl2? Which is the limiting reactant and which reactant is in excess and how many grams of it are left over? So to do this question, first of all, we have to write the balanced equation. So we have Al and Cl2 combined making AlCl3, right? AlCl3, and if I want to balance this one, if I multiply this one by 2, this is going to be 6. So to balance this one, I have to put 3 right here, and also we have 2 aluminium, so this is going to be 2Al right here. So now this one is balanced. Now let's do the problems. So we have this, they have provided this aluminium 114 grams. First of all, we have to convert this one into mole to figure out which is the limiting reactant, right? So to convert this one into mole, we have to know the molar mass of the aluminium. So mass of the aluminium is provided 114 gram, and molar mass of the aluminium is 26.98 gram per mole. If you divide 114 by 26.98, you will get the mole of the aluminium. So let's calculate that one. So NaL is going to be simply 114 gram of aluminium divided by 26.98 gram per mole. And if you calculate this one, you will get 4.23 moles of aluminium. So this is what we get from this one. So let's calculate the other one that is Cl2. So they have provided the mass of the Cl2, that is 186 gram. Molar mass of the Cl2 is 70.90 gram per mole. So to find the mole, we have to simply divide the mass by molar mass. So this is going to be 186 grams of Cl2 divided by 70.90 gram per mole. And if you calculate this one, this will give you 2.62 moles of Cl2. So now we have calculated this moles of aluminium and Cl2. Now we have to determine which one will work out, right? Like first of all, we have to find out when we have 4.23 moles of aluminium, how many moles of Cl2 required to finish this all of this aluminium. So we have to figure it out. So to figure that one out, what we can do, we can grab this moles right here, mole ratio. So I'm trying to find the chlorine, chlorine, right? So chlorine, I'm trying to find the chlorine required to finish this aluminium. So we have 3 moles right here. So this is going to be 3 moles of Cl2 divided by 2 moles of aluminium. 2 moles of aluminium, and that will give you the Cl2 required to finish this aluminium. And if you calculate that one, that will give you 6.35 moles of Cl2. So this is the amount required to finish this one. So let's see the other one. We have 2.62 moles of Cl2. So to finish this Cl2, how much aluminium required? So let's calculate that one. Secondly, so we have 2.62 moles of Cl2, and we are trying to figure out how many moles of aluminium required to finish the Cl2. To find that one, what I do, I take the aluminium ratio right here, it's 2. So it's 2 moles of aluminium divided by 3 moles of chlorine. So here we have 3 moles of chlorine, 3 moles of Cl2, and that will give you the aluminium required to finish the Cl2. And if you calculate this one, this will give you 1.75 moles of aluminium, right? The next thing is we have to check whether we have enough of this to do this one, right? First thing, we have 4.3 moles of aluminium right here. So do we have that? So here we have that amount. To use this one, we need to have to finish this one. We need to have 6.3 moles of Cl2. Do we have that? No. So this one doesn't work. So let's analyze the second one. The second one, we have 2.62 moles of Cl2. We have that one. To finish this one, we need to have 1.75 moles of aluminium. Do we have that? Yes, we have that one too. So this one doesn't work because we don't have enough amount of Cl2 to use this one, but this one will work. So now we have choose this one, and in this one we have to determine which one is going to finish first. And if you look at the amount of Cl2 we have 2.62 moles of Cl2 we have, right? So this one is exact amount we need, so this is not a problem. But if you look at the aluminium, that's 1.75 moles of aluminium, and we have excess amount of aluminium, so we can't finish them all, so this is excess. So whatever the one that finish first is going to be the limiting reactant. So this one, chlorine, will finish first, right? So this is our limiting reactant. So limiting reactant is Cl2. So that's the answer for the first question. Second is which reactant is in excess, and this aluminium is excess aluminium. And then the third question is asking, and how many grams of it are left over. So if you see, we have 1.75 we need to finish the Cl2. So excess is going to be the total amount. We have 2.62 moles total, and if you deduct the amount that we use, that's going to be the XX. So here, if I deduct this 1.75 moles of aluminium, that's going to give me the excess aluminium. So if you deduct this one, you will get, so let's see, so this one minus this one, that gives you 2.48 moles of aluminium. 2.48 moles of, oh wait a minute, this is, I chose the wrong number right here. Okay, here we have aluminium, that is 4.23 moles of aluminium, right? So 4.23 moles of aluminium, and we are using 1.75, so the leftover is 2.48 moles of aluminium. And the other one doesn't change because chlorine we have exactly 2.62, and that will finish first. And then what else we need? This one they are asking in grams, so we have to convert this one into gram. To convert this one into gram, we know that molar mass of the aluminium, that is molar mass of the aluminium, here we go, we have that one right here, molar mass, that is 26.98 gram per mole. Here we have mole, so if you multiply this mole by gram per mole, that will give you the gram, right? So to find the mass of the aluminium, you have to simply multiply these two. So 2.48 mole of aluminium multiplied by 26.98 grams per mole, and if you multiply this one, you will get 66.9 grams of aluminum. So these are the aluminum in grams are left over, right? So we have this information right here, but we didn't answer one more question right here. So what is the greatest amount of AlCl3 that can be made with 104? So they are asking for the amount that can be made with this experiment, right? So we are using 2.62. So always we have to use the limiting reactant to determine the AlCl3 we are going to create. So here we have limiting reactant, that is Cl2, that is 2.62 moles, right? First calculate the moles we are going to have, moles of AlCl3 we are going to have, then we can convert that one into grams. So we have 2.62 moles of Cl2, and then we have to find the mole ratio. So here we have 2 moles of AlCl3, that's what we are trying to find. So that's going to be on top. So on top this is going to be 2 moles of AlCl3 divided by the amount of Cl2. So we have 3 moles of Cl2 right here. So we are going to divide this one with that. So 3 moles of Cl2, and then if you calculate this one comes out to be 1.75 moles of AlCl3. So moles of AlCl3. Then you have to convert this one into gram to answer this question, because they are asking in grams. So we have to convert this one. To convert this one, we have to know the molar mass of this AlCl3. And if you calculate the molar mass is going to be 133.33 gram per mole. 133.33 gram per mole is the molar mass of the AlCl3. Now to find the gram, we simply have to multiply this mole by this molar mass, and that will give you the mass. So mass is equal to N times capital N, and we have 1.75 moles of AlCl3 multiplied by the molar mass of the AlCl3, that is 133.33 gram per mole, and if you multiply you will get 233 grams of AlCl3, and that is the answer for this question. I hope you guys liked this video. See you next time.